Hey science fans, welcome. Today we are going to talk about something that is useful in chemistry and biology, but it is a massive hint that this is going to be useful to you, Year 11 biologists. We're going to talk about surface area to volume ratio. I know, calm down. Let's get cracking. Okay, let's look at how you calculate surface area to volume ratio. Let's say I have a cube, because they are the easiest things to work out the surface area to volume ratio. Let's say the width of the cube is 2 centimetres and the height of the cube is 2 centimetres. Now I can work out the surface area of the whole cube by doing 2 times 2, which is 4. And then there are 6 faces on a cube, so 4 times 6, that would be centimetres squared. 4 times 6 is 24 centimetres squared. So that is the surface area. To work out the volume, we would do length times breadth times width. So we would do 2 times 2 times 2. 2 times 2 is 4, times 2 is 8 centimetres cubed. So the surface area to volume ratio is 24 to 8. And then we will whittle that down to a common factor. And the easiest way to do that is to do surface area divided by volume ratio, which is 24 divided by 8, which is 3. So it's 3 to 1. Okay, let's think about if we had a smaller particle, because we know that smaller particles react faster. So let's have a go at if we had a 1 centimetre cube. So 1 centimetre. So the surface area is going to be 1 times 1, which is 1. 1 times 6, 1 times 6 is 6 centimetres squared. Okay, if we want to work out the volume, it would be 1 times 1 times 1. 1 centimetres cubed. So the surface area to volume ratio is 6 to 1. So I have halved the amount of width and height of my cube. I've halved the size of my cube, but my surface area to volume ratio has doubled, because for this one I had 2 centimetres by 2 centimetres, 3 to 1. For this, I've got 6 to 1. So my surface area to volume ratio is 6 to 1, which means that essentially is the smaller the particle equals an increased surface area to volume ratio. Why is this important? Well, it's important in terms of diffusion. Smaller particles will diffuse faster. It's important in terms of requiring less substance in chemistry to make them react. That is how you calculate surface area to volume ratio. So you calculate the surface area, then you calculate the volume, and then you find a common factor. Okay, and generally, if you increase by a factor of 10, you decrease the surface area to volume ratio by a factor of 10. It's a directly proportional scale. Okay, that's how you work that out. Aside from really, really higher triple last question scenarios, they're only ever going to ask you to work out a surface area generally of cubes, or surface area to volume ratio of cubes, or they will allow you to work it out quite simply by telling you one of the factors and then getting you to calculate the other one. That's surface area to volume ratio. Done. Forgot to mention, single-celled organisms tend to have quite a large surface area to volume ratio. Generally, wherever you've got an exchange surface for things like gas exchange, you have a very thin surface which has a very large surface area to volume ratio. Maximum diffusion. I'm definitely done now. Bye.